let's try to understand what is this ANOVA. Name show analysis of the variance. The short form is ANOVA, right? So comparing mean of more than two unrelated, uncorrelated features or variable. Unlike a t-test, compare a two group mean, right? Rule, as I discussed with you in the t-test. Same here, we have some rules. If your data conforms the rules, then you should go for it. Otherwise, drop the idea. So your dependent variable should be continuous, right? Like a sales, height, weight, heartbeat, depending upon the data nature metric. Independent variable should be have how many category? Three, not three, more than two. Clear? So here, please have a look. Consists of a more than two category. Basically, three groups. Example here: high, medium, and low. Just think. It depends upon the data. So you should have a independence observations. It is like the same t-test, right? Outlier, again the idea. There should not be extreme value, not awkward value should be in the data set. You have to remove it. Dependent variable should be normal distribution, normal distributed for each independent variable. It means to say example here, high. So suppose sales is high. So under this category, data should be normal. Medium, under this category, data should be normal. Under low, data should be normal. If one of the category has not the normal distribution, you should immediately avoid this one. That's it. Okay, so have a look on the case study of the ANOVA, right? Let's try to do it here. I think here I have a case study for a sale promotions. Please have a look. And this case study tell a student basically experiment in which the major departmental store chain wanted to examine the effect of level in the in-store promotion, right? Because they want to make a promotion of their store or company, whatever. So experimenter wants to know the impact of the in-store promotion on the sale. So suppose if I'm investing the money on the promotion, maybe discount, whatever. So suppose, nowadays Christmas is coming something, right? So the companies are giving they are making their promotion. They are giving a lot of benefits to the customers. In that case, is it worth or not? Okay, so if I will spend a lot of money on the promotion, maybe my sale will be high, medium, or low, right? There are some levels. Just think about it. So in-store promotion was varied at 3 levels. High promotion 1, second code mean to say medium, and low promotion, right? So now we have the data set of the sale promotion. Okay, so let's see where is the sale promotion data set. Here, okay. Please see, this is the promotion value over here. Promotion value of what? Because it is already encoded. High promotion, then sale is this. If there is a high promotion, the sale value is this, like that. If there is a medium promotion, okay, and this is sale values like that. Practically, you can say if we make a high promotion, the sale is increasing. Just see from this data, we can easily see if there is a high promotion, obviously sale is increasing. If we don't make a investing the money on the promotion, the sale is not, because public will not know, right? So idea is to use this data set. So student, in this, how many classes we have? 3. How many sample we have? Like a 3, right? But how many record we have? 30. Okay, so we can analyze the data with the help of ANOVA. Okay, so let's go for our ANOVA slides here, right? You understand the case study. Now, please see the rule. And rule is again the normality. Okay, you can check for the three category, right? High promotion, medium, low. The p value is okay. Okay, why? Because the data is a normal and we have to prove this is it is good. The three category is good. Now I can tell that. Second was the equal variance. It is also good based on the average mean value. See, right? So now students, with these two things, I can see these data is okay for the analysis. ANOVA can be implemented. Okay, now how we can implement the ANOVA, right? So analysis, obviously ANOVA will also do the same, comparing the mean, right? But mean of three category. You can see here, you can see the one-way ANOVA. Okay, one way mean to say only the one way, like a very depends upon the variables, right? So again, there are a two-way ANOVA we will see, but let's see for the one-way ANOVA. One-way ANOVA, you will see you have to select the one-way ANOVA. Okay, and second step, you will see you have some dependent variable or something which variable you want to test, right? So my target variable should be the numeric value. Send it here, dependent list, right? And factor will be the categorical. Three classes we have, right? Okay, but here there is no need because it by default it is a three category. There is no need to put like 1, 2, 3, or there is light. Okay, so this is second step. Now student, what is the third step is we have to check the post hoc. We have a statistical a lot of post hoc tests. Post hoc tests will basically tell us it confirm the result actually, right? So in this, I'm using the Bohr-Forney test, right? So Bohr-Forney test will confirm the results. Where is the actual difference, right? So a lot of can be there, but mostly the people use the Bohr-Forney. It is important. You can Google it and you can find the Bohr-Forney. Okay. So now post of test, I can check it. So rest of thing is I think okay, because already if you want to check the equal variance, there are another test, but we already test the Levin test, so no need to use it. Okay, so now options, we have a lot of options for hit here. So descriptive, you want example, yes, we need a descriptive. So homogeneity of variance, you want the equal variance, you can check now again here. Previously you can check with another method, but here we have a facility. Okay, now Brown, this is also test for for the equal variance, I think, but there is no need. Welch, these tests are for the equal variance, but little bit formulas are different. Okay, but we are not worry about it. We are enough for the Welch. Welch is also a t-test. Okay, so here mean plot. Yes, you can also plot a mean plot, and level of confidence is 95%. You can, if you want to make a more sure, 99%, but by default 99 it is okay, right? So fourth step is done. Only four step for that one. Okay, let's see for the analysis, and the same window will show us the some results one way. Yeah, you see, you scroll down here. So here descriptive statics. Descriptive statics of the three category, right? Let's see for the here. So this is the per day sale here again. Descriptive statics will tell us how many store and how many, the mean value, average, everything is there. And test of homogeneous. This is the Levin test. If you remember, it is again good. We can use it. And the this table is important. ANOVA table, right? This table. I copy from there, and obviously you can copy from easily there. Copy and paste in your result file. Okay, so put it here. Try to understand that one. So please per day sale here. So see, there is a between the groups and within a groups. In the starting probability distribution, I show you the difference between the groups and within the groups, right? Okay, so in that case, obviously it will tell us, and also the degree of freedom. If there is it only three groups, the degree of freedom will be n minus one. So three group, 3 minus 1 like 2, and within groups then there should be 27, right? So here please have a look. This is a mean square value. This is only square of the mean value. Okay, and focus on the significant p value. It is less than 0.05. If it is less than, it means to say there is something impact, there is something difference. Okay, so impact of the promotion on the sales, you can also see from the your data set. I told in the starting, if we have a high promotion, obviously sale will be increasing, but we have to prove with the some evidence, right? We cannot say the things in the wind, right? You have to give the proof. This is good. Okay, please have a look here. High promotion, medium promotion, and low promotion here. Okay, so this graph is also showing like some negative bar here. Just think about it here. So if we do a high promotion, the sale is increasing. If low promotion, sale is go down. You can show by the bar. Now, but which promotion make impact on the sale? High, medium, and low. See, all type of a promotion impacted the sales. Okay, I told you post hoc test. Post hoc test will do it. So which test we applied? Von Ferroni, right? Which will post hoc mean to say after the analysis. After ANOVA, whatever the result, it will be checked by that one. Okay, so see, the significant value is okay in the all cases. Yes, it means all the tests or all the promotions are good. Low promotion, if you will do, obviously there will be change, but not high sale. If there is a medium promotion, there will be some change, but not a good. But better is to be high promotion. Okay, but according to this data set, because we have only 20 store data or 10 store data only, right? But in the real life, if you have a more and more data, you can give a very good result. Okay, so that's why the post hoc test. Now in the last student, we have to report our results. This is the way how to report. So there was a significant effect of the promotion on the level of the sale. Okay, this is the F value which we counted. This is the F value for the ANOVA, and 2 mean to say the group n minus 2, degree of freedom, and this is the value, and p value less than 0.6. If it is greater than, it mean to say no need to invest the money on that.